Very good morning, dear students. Oscillation, the chapter started here. The next concept in yesterday class we were discussing that the velocity of simple harmonic motion. The velocity of the particle which is executing the simple harmonic motion, that is oscillating or which is continuously, it is moving a periodic motion here. Okay. Oscillates. How to draw that oscillation of the displacement, oscillation of a particle with respect to displacement as well as velocity. One wave diagram is there. Okay. Next here today discussing the velocity of a particle executing simple harmonic motion, and I gave you one homework, that is just differentiate that displacement with respect to time. Okay. Now its definition is here, that is the rate of change of, the simple definition is the rate of change of what? Displacement of a particle. Yes, it is a displacement of a particle executing simple harmonic motion. Yes, that's right. Executing simple harmonic motion is called velocity. Is called velocity. At a certain instant of time is also there. Is called velocity. Okay. Now, according to its definition, that velocity is in terms of capital V. Okay. V is equals to dy by dt, where y is the displacement of a particle executing simple harmonic motion, where y is the displacement of the particle. Its equation is A is an amplitude which is a constant, the sine of omega into t. If there is some initial phi, that is initial phase, that is phi naught, if there is some initial phase. Okay, this is the displacement equation. If you substitute this one in the equation number 1, that is the velocity, then velocity become what? The d by dt of A into sine of omega t plus of phi naught. Okay, it is plus or minus. I'll take here on plus. Okay. Now, this is called the initial phase. The initial phase, it means at time t is equals to 0, it is always constant. Where phi naught is called the initial phase. Initial phase at t is equal to 0. At t is equal to 0 means it is always what? Constant. This initial phase is constant here. We have to differentiate this equation, that y is equals to A into sine of omega t plus phi naught with respect to time. Here the displacement is only depends on the time, that is t, because the A is an amplitude, omega is angular frequency, both are constants here. A and omega are also constants. Okay. Now, just velocity is equation number 1 become what? Differentiation of this whole equation. Okay. Here A is constant outside. Differentiation of the variable is only t, the whole term is sine omega t plus phi naught. Omega t plus of phi naught is there. Okay. The next part is the differentiation of this is completely what? Theta. This is completely what? Theta is an angle here. Okay, if it is theta, this is sine of theta. Consider the sine of theta. Sin theta means differentiation of sin theta means differentiation of sin theta. Okay, I'll write some value here. Consider that omega t plus phi naught is what? Omega t plus phi naught is a theta here. If you write the value of theta is here, at here, that means the a is a constant. Differentiation of sin theta is cos theta. Okay, differentiation of sin theta is what? Cos of theta. Because here differentiation of sin theta with respect to time. Sin theta with respect to time is cos theta, and this is not a term of t. So because it is an under term, it is an under variable, so it is not a time, it is not a term of t. So that here we have to write the dt by d, d theta by dt. It is a partial differentiation. Okay. Next, you have to write here. We have to write that d theta by dt. Okay. D theta. Theta means what? Omega t plus phi naught. You have to write here omega t plus of phi naught. Then cos theta is over. After that, d theta by dt is d theta means what? D by dt. Theta means what? Omega t plus phi naught. Omega t plus phi naught is there. There are two terms. One is omega t and another one is phi naught. This is in the form of differentiation of u plus b. Differentiation of u plus b. I'll write here differentiation of u plus b is, its form is differentiation of u with respect to t, then the plus of differentiation of v with respect to t is there. Apply this form. Apply this form. Okay. This is a reference. I will write here the reference. Okay, this is the v velocity. I will differentiate completely here at here. Now the velocity is equals to a into cos of omega t plus of phi naught. This is one form. We have to write this. We have to differentiate this u and v separately here. Du by dt is nothing but what? D omega t by dt. Here into d omega t by dt plus of what? D phi naught by dt is there. But this phi naught is constant. Phi naught is what? The phi naught is initial phase, which is constant. Phi naught is constant. So that differentiation of constant is 0. Differentiation of constant is what? 0. So this term become what? 0 here. And we have to write the t term is here only. The remaining, that is coefficient, that is omega, become outside. Different constant outside, differentiation of variable. Here the time is a variable, right? So that we have to take this omega outside. Then a into cos of omega t plus of phi naught as it is. Here phi naught is there because we are differentiating the trigonometric function. So that here theta angle is same. Into constant outside means omega outside. Differentiation of here dt by dt is there. Dt by dt is nothing but differentiation of a term with respect to same term is 1. Differentiation of x with respect to x is what? 1. I'll write the reference purpose here. These are the reference using those forms. Okay. Then v is equals to a into its form is, its value is 1. If its value is 1, omega here a into omega into cos of omega t plus of phi naught is the equation of what? This is the equation of velocity in terms of trigonometric function. In terms of trigonometric function with respect to harmonic function. Okay, this is the velocity with respect to harmonic function. Okay, the velocity, this is the velocity in terms of harmonic function. Harmonic function. We have to remember this equation also. Call this is equation number 2. Here equation number 1 is, here equation number 2. Now we have to write this is in terms of displacement, because velocity in terms of displacement means what? Here cos of omega t considered, this omega t plus phi naught is considered as a theta is, okay, this cos theta considered cos theta. Then v is equals to a into omega. Cos of omega t is there. I'll write one equation here. Here we know that the sin square theta plus cos square theta is equal to 1. We want the value of what? Cos of theta. So cos square theta is equal to 1 minus of sin square theta. Then cos theta is equal to what happened? Root of 1 minus sin square theta. We have to write like this. Then cos of omega t plus phi naught is nothing but what? 1 minus sin square omega t plus phi naught. Same. I'll write this cos of theta is nothing but a root of 1 minus sin square theta is nothing but what? Omega t. Omega t plus phi naught. Omega t plus phi naught. Then we have to write one form. We know that one equation, the displacement equation, that is y is equals to a into sine of omega t. Call this equation number 3 here. Okay, right, only omega t plus of phi naught. But we want the sine of omega t plus phi naught, because it become what? Sine of omega t plus of phi naught. This become what? Y divided by a. Y divided by a. Then here put the equation number, put in this equation number 3 here. Put in this equation number 3. Put in equation number 3. V is equal to what happened? Directly, I write directly here. A into omega root of 1 minus of. Here sine of omega t plus phi naught is equal to y by a. Here square is there. It means y divided by a whole square becomes y square by a square is there. I'll write directly here y square divided by a square. LCM here is 1. LCM is a square. Okay, a square is LCM, or if you take the LCM like this, cross multiplication and denominator multiplication. Cross multiplication means 1 into a square is a square, 1 into y square is y square, divided by denominator multiplication is a square into 1 square is over here. Then a into omega root of this complete whole root. You have to write the whole root. The root of a square minus y square divided by a square is there. If you taking this denominator outside, root of a square is nothing but a. Okay, then these two gets cancelled in root. These two gets cancelled. Next, directly the velocity equation is here. Velocity is equals to omega into root of a square minus of y square in terms of what? Displacement. Here the maximum velocity and minimum velocity is also there. Those are depends on this angle theta as well as this depends on this displacement also. Okay, theta is nothing but what? Here t is there, na? The t become like that. Okay, this is the velocity of the particle executing simple harmonic motion. If it is the velocity in terms of trigonometry, in terms of harmonic function cos of omega t plus of phi naught, or if you write that phi naught is the initial phase constant, it is considered as a 0, that become what? A into omega into cos of omega t only. Okay, this is the omega t. After that, we'll write the conditions for the maximum velocity and minimum velocity. Next is the conditions for the maximum and minimum displacement as well as the maximum displacement as well as maximum velocity. Minimum velocity and minimum displacement also. I will write the wave diagram also here, or the oscillation diagram is there. If there is the displacement of the body, you consider this is the displacement here. It is a displacement and time graph is there, graphical representation of that. The time is along x-axis and displacement along y-axis. Here it is y minus y. And here I will write the velocity. I will draw the velocity of that. It is a velocity time graph. It is minus v and it is a plus v is there. Okay, this is the time. Okay. Here, at this origin, the origin is nothing but what? It is a mean position. It is a mean position. And here the omega t is 0. Consider here the phi naught is an initial phase. It is completely 0. Because time is 0 at here time is 0. So it is 0. Here also the phi naught is considered as a 0 and here the omega t value is 0. It means consider theta is 0. After that, I'll make it clear. This is the 4 part. One is for one revolution, for one period, the total angle is 2 pi. The total angle is how much? Up to here. I will take the here. That is, the total angle is 2 pi. Up to here, the angle is 2 pi. The total time for one period is also what? Is a time t is there. Up to time, consider time. The time is a t. Here it is t. In both here and here. T is a time period. Half of that means what? Its velocity, its displacement, or its angle become what? Pi. Pi. Here also its angle is pi. Half of that, it is pi by 2. Pi by 2. Here it is pi by 2. And here it is 3 pi by 2 and it is here 3 pi by 2. The total time for half revolution or a half period is t by 2. Here it become what? T by 2. Here it become what? T by 2. And this become what? T by 4. T by 4. It become 3t by 4 and this 3t by 4. Here t by 4. T by 4. Okay, I make here the 4 parts. 1, 2, 3, 4. We have to draw this diagram. Displacement equation is there. The displacement equation that y is equals to a into sine of omega into t. And v, velocity is also there. Velocity is equals to a into omega into cos of omega t. Omega t is only there because phi naught is 0, na? Okay, omega t is also only there. We have to check where displacement is maximum and when the velocity is maximum. Okay. First, if omega t is 0, it means at t is equal to 0, na? Here it is t by 4, but the t is equal to at here 0. Okay, here t is equal to 0. At t is equal to 0. If t is equal to 0, then omega t is equal to what? That is also 0. The phase is what? 0. Omega t is also what? 0. I'll calculate only one part. Remaining part will be 1. Okay. Next here, omega t is 0. If omega t is 0, then what about the displacement? This is 0. It means what? That particle starts from its mean position. Here, it starts from here only 0. This is called what? The minimum displacement. This is the minimum displacement. Next is at t is equal to, after that t is equal to t by 4. T by 4. Okay. If t is equal to t by 4, add this t by 4, the total omega t is how much? Pi by 2. Omega t is an angle, so its angle is pi by 2. If it is pi by 2 is nothing but a 90 degree. 90 degree, here sine 90 is 1. What? Sine 90 is 1, that y is equal to what? A. This is what? The maximum. This is what? Maximum condition. Like that, at t by 2 again becomes 0. T by 2 means the angle is pi. Angle is pi means what? Again sine pi is the sine 180 is again 0. Then cos it means y is equal to again 0 here. Then same term at here. At t is equal to 0. I'll draw here. This is the graph. It is a maximum. At t by 2, at t by 4, the displacement is maximum. Here y is equal to a. It is what? Maximum. Afterwards, at t by 2, it become what? Minimum. Minimum means what? Again maximum. Again maximum. Then minimum is there. Here also maximum in negative direction. Y is equal to minus a. Because 3 pi by 2 is third quadrant. In third quadrant, sign is negative. In third quadrant, sign is negative. So that sign negative is sign 90 is again 1. It is 180 plus of 90. Okay, negative is there, minus of a is only there. Then it is minus a. Then again it is 0. Here is a maximum. It is also considered as a maximum, and this term is y is equal to 0. Here also y is equal to 0, considered as a minimum. It is minimum. The minimum condition for displacement is y equal to 0. The maximum condition for displacement is y is equal to a. Then if t is equal to 0, at t is equal to 0, what is the omega t? That omega t is also 0 here. Then what about the velocity? Velocity, it means if omega t is 0, that cos of 0 is 1. Cos of 0 is 1 means its value is only what? A v is equal to a into omega. A into omega. This is what? The maximum. The maximum velocity. The maximum velocity. It means what? At t is equal to 0 means its mean position, it starts from what? Not here, it starts from the maximum value. Maximum value is nothing but a into omega. It means positive, consider here. It starts from the maximum value like this. Here, v is equal to a omega. That is maximum. This is called maximum. At here, it is become minimum. How it become minimum? A at t is equal to actually t is equal to t by 4. T by 4. At that situation, omega is equal to pi by 2. Pi by 2 means it is a 90 degree. Cos 90 is 0. If cos 90 is 0, the velocity become what? 0. Here the velocity become 0. Then it become, I'll write, under third one is also there. T is equals to T by 2. That at that situation, if it is T by 2, angle is pi, then y is equal to 0. Again, it is minimum. Then at T is equal to G, at T is equal to here T by 2. T by 2. Then omega T is pi. Then what about the velocity? Here it is a minimum now. And the velocity is what? T by 2 at pi is there. Pi is nothing but 180 degree. In second quadrant, cos is what? Negative. In second quadrant, cos is negative. This become what? Minus of omega into A. Yes, again it is maximum in negative direction. Like this, it is maximum in negative direction. It is considered as a maximum. Or it is V is equals to A into omega. After that at here and like this. The graph of velocity is like this and the graph of the displacement is like this. Okay, here the V is 0, considered as a minimum. Here also V is 0, considered as a minimum. It is a maximum, it is minimum. Those all are there. Okay, now one important is the condition conditions for maximum and minimum displacements and velocity is here. Maximum condition, when the displacement is maximum, y is equals to a. When y equal to a, what about the velocity? Maximum condition is there. The maximum is v is equal to what happened? A into omega is a maximum condition. It is y maximum, then this is a v maximum conditions. And minimum conditions are also there. If y is equal to 0, then v is also what? 0 is a minimum condition for minimum and maximum condition for a displacement and velocity of the particles. These are the graphs for velocity and the displacement of the particle executing simple harmonic motion. In next class, we will discuss about the acceleration of the particle executing simple harmonic motion and the maximum and minimum condition. Afterwards, some problems on this one. Okay, thank you.